Good afternoon, students. We are going to discuss the module 1 of Signals and Systems introduction part. In that, we have discussed signals, classification of signals, and then independent variable, dependent variable, and with related to that problems, everything. Now, today we are going to discuss the system, properties of system. Okay. So properties of systems, that is stability, memory, causality, invertibility, linearity, and time shift invariance. These are the properties of the system. Okay. And now what is meant by stability? Stability means nothing but a system is said to be stable if it should have bounded input for every so it should have bounded our input and bounded output, that is stable. If the bounded output results in the bounded input results in the bounded output, then the system output is stable. Okay, that system does not diverge and the input does not diverge. If the input does not diverge means your output also will not diverge. Okay, so here this is x of t is nothing but your input and y of t is nothing but your output. If modulus of y of t is less than or equal to my, if it is less than infinity for all values of t, when modulus of x of t is less than mx less than infinity for all values of t. If this is if x of t is less than infinity, then obviously your y of t is also less than infinity. This is about your stability. The next one, memory. Memory means if the output at any instant depend only on the input at the same instant, then it is said to be memoryless system. Okay, if the output of system at any instant also depends upon the previous and future input, then it is said to be memory system. For example, memory system, if see it is having this n minus 1 is nothing but your previous value, x of n is nothing but your present value. Without memory means there is no shifting or multiplication with time. That is nothing but memoryless system. This is the examples of memory system and memoryless system. Next, causal system. A system is said to be causal if the output at any instant of time depends only on the current values and or the previous values of the input. That is, the output of the causal system does not depend on future values of input. Okay, a system, it is said to be causal if the output at any instant of time depends only on the current values and not on the previous values. Okay, sorry, and on the previous values, but not on the future values. Then it is said to be causal. That is, y of t is equal to t into x of t. Suppose if the system is depends upon the future values, that is x of t plus 1, then it is said to be non-causal system. The next one is linearity. Linearity means a system is said to be linear if it is satisfied two conditions. One is additive property, other one is scaling property. Okay, one is additive property, other one is scaling property. Next one is time shift invariance, means a system is said to be time invariant if the time advance of the input signal results in similar delay in the output, then it is said to be time shift or time delay. Okay. Here one more topic, that is system viewed as interconnections of operations. Okay, a system can be defined as an interconnections of operation that transforms the input signal into output signal without properties different from those of the input signal. Means that system interconnection means the system will have interconnection. Okay, interconnection of operation means addition, subtraction, multiplication, shifting, folding, all the connections will be weaved. A system consists of all types of connections. Okay, and then we can perform the operation. So for example, signal t, okay, function mapping is x of t. Same thing, the function mapping is y of t. Okay, so if the input is given to your system, then you will get the output with here this h is nothing but your operator. The system will do some operation on the input and you will get the output. So h of x of t. The same thing for your, this is for your continuous. So we will see the problems on properties of systems. The first problem, check the stability property. Check the following properties like stability, causality, linearity, time invariance, memory for the system. Here y of n equal to a x of n plus b. Okay, so we have to check the stability. First one, you know the formula. If x of n is less than mx less than infinity, definitely your y of n is also less than infinity. So what is meant by stability means, if the input is bounded, definitely your output also bounded. Okay, every bounded input should have bounded output. Okay, every bounded input should have bounded output. Okay, so in that way, so here what we are going to do, first, here I am taking x of n equal to mx less than infinity. So this x of n, this y of n is nothing but a x of n plus b. What is x of n? X of n is nothing but mx. What is this one which is less than infinity? So here it is mx. What is mx? The mx is less than or equal to infinity. So the given system is stable. Okay, the given system is stable. And the next one is causality. Causality means what I told. If the system is said to be causal and it does not depend on the future value, that is n plus 1. Here there is no plus or minus shift in the time. So the given system is causal. The next one is linear. Linear means it should satisfy the to satisfy the superposition principle. So the superposition principle includes additive property and scaling property. So here if my x of n is a x of n plus b. Okay, a x of n plus b. If I put x1 of n, my input also x1 of n. If I put x2 of n, my input also x of 2. This is the standard formula you should memorize. Okay. Here this a is nothing but your scaling value and this plus is nothing but your additive property. Both it should satisfy. Every linear system should have, so to satisfy this scaling and the additive property. So here I have multiplied a, capital A with x1 of n. You can use any factor. Okay. Here I am having already a, that's why I am using capital A. Otherwise you can use some what is that? Yes, T like that. But generally we will use yes, A, B. Okay, input will be X and output will be Y. So here I multiplied A. So wherever X of n, there I should multiply this capital A. So here X of n is here. So I'm going to multiply A into A, small a into A x1 of n. Wherever x2 of n is there, there I'm going to multiply B. So B into x2 of n. This is nothing but my input. Okay, next I'm going to take the right hand side. Right hand side is a y1 of n, a y1 of n. So my output is what? What is my output? A x of n plus b. That is my output. It is given in the question. Okay, my output is a x of n plus b. So I'm going to multiply a with y of n. So that is the thing here we are going to prove here. Okay, a is multiplied with the y1 of n. So the total a is multiplied with the entire signal. So a into a x1 of n plus a into b. Okay, and the total signal will be multiplied with your b. So b into, sorry, y output. So b into a x1 x2 of n plus b into b. So see, if I add this 2 here, so I will have a x1 of n plus b, a b. Sorry, a capital A small b, and b into a x1 of n plus capital B b. Okay, so this one and this one is not equal. So the given system is not linear system. Okay, and the next one I'm going to find the time invariant or not. Okay, time invariant means this is my output. This is the given system. My system is having the output a x of n plus b. Here if I shift my input by n naught times, the same amount of shift should be takes place in the y of n. So I'm going to shift my input. Input is what? X of n. X of n minus n naught. In this output, what is your input? X of n. If I shift the x by x of n by n naught, so now a into x of n minus n naught plus b. Now I'm going to shift the output. What is my output? A output here A is wherever I am shifting here only x only having here only you are having n term. Remaining all places only constant is there. If I shift to y of n minus n naught, the A into x of n minus n naught plus b. This is time invariant. Memory means so it does not having any positive shift or negative shift. So the given system is memoryless system. Okay. Thank you students.